one. I already posted on one YouTube. I'll put it out on some more so people can have ample opportunities. If you go to our website too, in case you wanted to just use, we have 4 webinars, a little bit longer format, but if you go on to Fly to Learn, I'll bring it right up now. I want to show everybody this anyways. If you go to Fly to Learn, log under educators. I think we have, let me see who's on here tonight. Reza, if you'll send me a video of your schools, how they did last year, I would love to have it. We'd love the link to it to show everybody, share what a great job your kids did. Anyways, if you go here, you can see videos. We even have that break down little parts of this that you can watch. Quick, and then quick with no sound, like how to do flight setup, set payload, takeoff. No, with sound. But we have Fly to Learn webinars right here, and those will actually go through the 4 lessons. So these will actually go a little bit right here. They are. So here's 1 and 2, 3 through 6, 6 through 10. We're kind of cutting it down to 2 webinars just to get everybody started, okay? So I just want you all to see that you can be looking at those. You can use them in class. We made them available for everybody to use them, okay? Now, let's go back. We've got that. I want to go ahead on our slides. Let's talk a little bit about today's. We're going to hit lessons 1 through 6, okay? Do we have any questions? Raise your hands if you have any questions. All right. And everybody can hear, everybody sees Introduction to Fly to Learn Part 2, Lessons 6 through 10. Correct? Raise your hand if you can see that. All right, good. Excellent, excellent, excellent. All right. Now, here we are. Here's an airport. It's Lawi. We did this to start off. This was the quick flight setup. In a few minutes, I will get X-Plane back out so you can all see this. If you have X-Plane with you today, that would be great to have it set up on another computer. We're going to be using Plane Maker tonight. That's our big goal. So you can start trying out some different ideas there with Plane Maker. All right. So you go to quick flight setup before you jump down to here. That's where you set your airport to Lawi. For the most part, that's what you want to do. Then you want to go to General Aviation Cessna, where you take that airplane right there, open the aircraft and use it. We tend to use the Cessna 172, and we use a King Air in the first 5 lessons. And you're going to set your air to clean. Don't have them flying through storms, etc. All right. You know, poor visibility is what kills a lot of pilots. We don't want to get them in a bad habit. And Randy Witt, who's the other co-owner and has, I don't know, thousands of hours flying, feels very strongly, and I agree with him, that we don't want to teach the kids a bad habit, because we know some of the kids that use the software are going to go on and become pilots. So keep the skies nice and clear for them, all right? Now, don't encourage them to be flying in thunderstorms, is I guess what we're really trying to say here. Okay, now, when we go to take off, it's simply a 3-step process. We pause it by hitting the P key. We turn off the brakes. We push the throttle in. Then you unpause it, and it'll taxi down the runway. Remember, we click and we stay in that white square. We talked about that. We also talked about, by looking at data input-output, we can collect lots of different information with this software. There's 131 data points. I don't think you'll need them all, but it's good to know you have them there. Speed, distance travel, landing gear, and vertical force is what we use primarily. We're able not only to see it on this cockpit, when you show it as a cockpit display, we can also graph it. And that really is the power of this software for us to use it in the classroom. And the plane maker, to be able to change the airplane and it will fly differently because of your changes. You can, when you're graphing this, remember they have all these check marked. You can uncheck these, most of these, and just use what you need. You need to know the landing gear, you need to know distance traveled, and you need to know your airspeed. That's usually the things we're measuring. Right at this point here, you can see the red, the yellow, green. That's the landing gear. They all went to 0 at this point right there. And once they go to 0, and in fact over here where the white line is, you can see it's all 0, 0, 0. All right? And that's what we define as takeoff. And we practiced in the last lessons. We practiced. We talked, why an airplane flies. We talked about weight. We talked about lift being a function of both airspeed and angle of attack. We talked about drag, induced, parasitic, induced being drag created by lift itself. But there's so much more lift to drag that it's worth it. We'll pay that cost. And then we talked about, adding flaps to an airplane. It's best of both worlds when you're trying to landing. It slows the airplane down and increases lift so you can fly at a lower speed, because just the lesson before you learned that airspeed plays a role in lift, and if you didn't create other ways to create more lift, if you slowed the airplane down, you might have it fall out of the sky. Lesson 5 was practice landing, and we did that by just changing the throttle. Set the RPM to about 1600 RPM. You kids want to push the nose down, up, all around. It's just try to fly the plane level. You set it at 1600 RPM, it should come in for landing. Okay, so that's what we covered in the first webinar. Do you have any questions? Okay, no questions there. Let's go on to flight controls. And this is the PDF for flight controls. And I should say this. We usually do in my classroom, this is for the teachers here or people in a club, this is an ideal time, I think, when you get one of these cheap little airplanes and you improve them. If you take one of these jet streams and they come like this and they're $2 and it's plastic rubber band here, or poor rubber motor here, kind of heavy really. What we do is we talk about airplane stability, and then we've had them fly this. Okay, and then we start thinking about, well, how can we make this fly better? So then we might go back and have them talk about flight controls and stability. All right, now you can go right to lesson 6 and don't even do this. But we find that it's a good way to, hey, virtual is great, but honestly, I like to see kids build model airplanes again, too. I'm doing a lot of work, and if everybody's interested in talking about this after the webinar, I'd love to talk to you. I'm now moving a lot into foamies. We're using something from the Brooklyn Aerodrome. It's basically a Delta wing plane, and we're moving towards using that with Fly to Learn and with my kids in my high school classrooms. I'll keep you posted how that's going. All right, now, so you have the stability. Let me get the PDF I'm trying to get down here. Bear with me one second. Never fails. All right. Here it is. All right, so I'm going to go through teacher's version of this. All right, now, this is all dependent on what you're trying to get out of this on a Fly to Learn. If you can go into more depth on this if you want to, you don't have to. We've got pitch, yaw, and roll. All right, you got pitch, yaw, and roll. All right. Now, what they can do is, let's say they go to the runway and the first thing, and all they do is move their mouse around. You use the A so you're behind it, move it around, and just see when you're turning the mouse around, what is it doing to the controls? Let me go ahead. I'll bring up X-Plane right now, and I'll show you what I'm talking about. And if you've got it, go ahead. Our version's 9.71. That's the version you probably want to make sure you have in there, only because there's some special features in it. All right, so what I'm saying is, if we come out in the airplane, sorry about that. We click here, we get this white square. Well, if I use my mouse up and down, I'm changing that back elevator. If I go left or right, I'm changing the ailerons and the rudder. And the kids can see what's going on there. That elevator is going to change, the angle of attack on the airplane. Elevators. Talk about coordinated turns. You can talk about adverse yaw. If with those folks here that have got a pretty strong piloting background. All right, so again, let me use my arrow key. This X, you can also use your arrow key, move around this way and do it over here. It might be a little bit more obvious to the pilot. All right. If it's coming across choppy on your end, it's not the software, it's the internet. The webinar stuff doesn't move. All right. All right, so everybody, if you got a chance, go ahead and do that real quick if you got. Now, so that's part of lesson 6. And that's just getting them what the control surfaces are. All right. I'm going to pause this. Move this down a little bit. Okay, after we do that, we start talking about stability. And one thing kids will do, they'll start talking about stability and etc. Or they'll go out and they'll fly that plane, say build that little stick plane, and it does loop-de-loops and crashes. And every student I ever have that flies a very unstable airplane will always say, oh, it's a stunt plane. No, it's a junk plane. It's not a stunt plane, right? So what we want to get them to realize is while lift is important, thrust is important, stability is every bit as important. So we start off talking about why an airplane has a tail, and think of a tail on an arrow. Without it, your arrow will start to, if there was no, the feathers on a tail act as a negative feedback loop to any kind of disturbance in the air heading the arrow. If you shoot that arrow, try to shoot it, say, 50 yards, by the end, they discovered without feathers, many times the arrow would begin to tumble. Because if there was a force coming from the left, the arrow reacts by moving in that direction to counteract the force coming from the left, or counteract. It acts to dampen that force is a better way I should be saying that. Okay, a tail on an airplane does that. And then we talk about roll and yaw stability a little bit. The one that we spend most of our time really talking a lot about, though, is pitch stability. Now, here's something that a lot of pilots don't get right, or certainly a lot of model airplane makers don't get right. Okay, let me show you this. Well, I don't mean to do quite that. Let me hide this down so you can see this. Okay. When this airplane here if we take a look at a moment here, there's a center of gravity and there's a center of lift. Center of gravity is theoretically I could hold my finger under the airplane, and if I could hold the weight of the airplane, I could hold and the plane would balance there. Center of lift is where basically all the lift would balance from. That point in the airplane, it's center of lift we're worried about, because we want the center of gravity to be slightly ahead of it, generally in most designed airplanes, and then the tail is behind it. So you're balancing really the tail moment arm with the center of gravity moment arm. We can't change the center of lift in the wing, but we can change the center of gravity, and so that's why we balance out the airplane. And model airplane people talk all the time, and I'm one of them, about changing, hey, where's that center of gravity? Let's balance that wing according to center of gravity. When in reality, it's the center of lift never changes. We're just moving. It's generally about a third of the way back on the wing, and you generally can't change that. I suppose when you put the flaps down, you're in effect changing that center of gravity, center of lift a little bit. But we really talk about that center of gravity, and so we want that input or tail moment arm to equal the output or center of gravity moment arm. All right. So you have tail moment arm balancing, and they're all in the fulcrum is that center of lift. It's not the center of gravity. The fulcrum from the tail moment arm. What's the tail moment arm? Well, that's the distance from the center of lift back to the forces on the tail. On your Cessna 172, you can see the left vectors are going in the opposite direction. On the front of it, it's the center of gravity moment arm, and it's just slightly in front of it. It's in front of it in just a matter of inches. And the way to think about that is a teeter-totter, right? You have your little daughter or your little sister, you put her way out from the fulcrum, and then you move up as close to the fulcrum as possible for you all to balance. So we kind of talk about that. And then we go into more detail to really stress this. So if you got these two toads or two frogs, this frog weighs 5 pounds, this frog weighs 10 pounds, then the smaller frog needs to be 2 feet away from the fulcrum, as well as the bigger frog is only 1 foot away. And it ends up working out the same. Same idea here with the airplane. All right? Why does that become interesting? Well, if this tail moment, all right, and the center of gravity moment are equal, the plane's flying level. If that tail moment is producing more force than the center of gravity moment, it's climbing. Vice versa, if the tail moment's producing less, then it's going down. And again, this would be how much weight you put in the airplane, because you're really not going to be able to change the tail moment all that much, right? So this is one of the reasons it's so important for small model airplanes, for you to glide them and balance them. Same true for adult airplanes. Everybody in here who is a pilot knows they go out and they do their weight calculations. So we actually do that in the airplane. We have the kids fly it. They can actually change the elevator deflection, how much you're pushing the elevator, and we sit there and change the center of gravity on the airplane. And it's in inches, and it's not very much, and it really plays havoc trying to fly the airplane. We also, from a tail design question, say, hey, if you have the same amount of force on that tail, so all we can do is really change is the tail moment arm, you can see that airplane B and airplane C are going to be producing different forces to balance that airplane. This is why if the tail is really far away from the center of lift, you can have a much smaller tail. And you're going to have a beefier tail. You're going to have a low, that's producing the tail producing more load if it's closer to the center of lift. All right? Once we've done that, we talked about stability, we've done all those things, then you go in and have the kids, maybe they've already built flown like that, and then go in and let's do some things to fix it. Well, let's put a dihedral on it. Let's put a bigger motor that's got more power on it. Let's get rid of any weight we don't need, because now we've dealt with all the forces and stability. You can wind this bad boy up and fly. So this will go from like a 2-second, 3-second flight to 5 to 7 seconds, 10 seconds. All right? I just went through a lot there. Any questions? No one has a question. All right, then I must be the world's best teacher. All right, guys and gals. Okay, now let's go down, and I want to talk to you about the next part of this. Now we're going to move really heavily into the engineering side. Lesson 7 gets into this. And we're going to start talking about aspect ratio. All right? And we're trying also to show students and folks that being engineers and designers, we want to use math as a tool. If it can save us work, let's do it. So the first thing we start off with aspect ratio, and we just have found out that if the aspect ratio gets much below less than 1, it's not going to take off. And if the aspect ratio is 12 or greater, that's a problem for other reasons. Structure, for example, our design specs call for it to be 12 or less. That might be, we'll get into why in a moment, why aspect ratios, why not all airplanes have high aspect ratios or the same aspect ratio. Okay? So we're going to come to that in a minute. But first thing we're going to do is find out which ones the plane will not fly. And so we take the wingspan and divide it by the mean chord. It's not quite accurate to say the average chord, but for right now, let's just say chord, which is the width of the wing. So wingspan is the length of the wing divided by the average width of the wing. All right? Or the mean of the wing is really better. Okay? And then we're going to go into Plane Maker and make a plane's identical plane, but we're going to change the wing so it has different aspect ratios. This would be really helpful right now if you will go into your program and bring it up. I'm going to go in. It's found, X-Plane, Plane Maker's found right in the same folder with the X-Plane. So my folder in this case is X-Plane Fly to Learn. If I go in there, we should. I don't like it when it does that. Why does it do that? Okay, hopefully we'll be all set. Here we go. I'm going to bring this up. Top hit. Here we go. Plane Maker comes right up. Raise your hand if you have this up, you've brought Plane Maker up, or you don't have X-Plane and Plane Maker, you can't even get to it during this webinar. That way we're not waiting for you on that. I'm going to give the people that can get to it can turn it on and bring it up. So let's get everybody pull up. If you can, let's get Plane Maker up. We're going to make a lot more out of this if we do it this way. All right, I've got 4 of 12. We got one question here. Let's go ahead and pull this question. And it always blows up. Should we have loaded the Cessna? I'll show you how to do it. You probably are going to be something like this. If you load up there and it looks like this, don't be shocked. It'll be either a grid or a bar like that. If that's the case, don't worry. We load the 172 ASP, that's fine. We're going to use a different airplane, but that's fine. We're going to be ending up using the, well, let me show you. Just give me 1 second. You don't need to even have an airplane on here. We'll get you going in a moment. Hey, Reza. Hey, Reza.
Yes.
Hey, do you think you can send? Do you have another video we can show what the kids are doing? The school never, their link went down, and I'm using a newspaper article that was done about you guys. You wouldn't
Oh,
have anything else, would you, anymore?
well, I do. We have that video from Channel 5 up in Seattle.
Okay,
I don't know. Is that something that would be helpful?
that might be something. We have one. We have the video. I thought it was in D.C. Is that this? Am I thinking the same video, and I just have the wrong location?
Yeah, I think so.
All right, all right. Well, I have that video. We'll use that then. I didn't know if
Well,
you put anything
I'm
else
going to send
together.
you a link.
What's that?
I'll send you a link, and it has a couple of different videos on there.
Very good.
And,
All
and
right, thank
maybe.
you.
Sure.
Uh, his team did very well with some kids that have some challenges the rest of us may or may not have, as far as financial support their school can provide. And Ray's group did a just bang up job last year. Yeah, he just sent me this. If you get a chance, if it's all right with him, I'll put this link out. Um, well, I'll put it on our website if it's all right with him, and then we can. Let me copy this. Okay. I'm going to drop this right into something else here. Right. And now I have it there. I'll have it after the event. I don't have to worry about it. All right. Hopefully by now, most everybody has gotten that's going to have it up there. I still, people, raise your folks. If you'd raise your hands, it'd be really great. That way I understand if you have it up there or not. Okay, great. It's my, just leave your hands raised. I'll lower them. You raise them, and that way I know indeed if we're set to go. All right, we still got a few more people. If you don't think you can, you don't have Fly to Learn at home or whatever, and you can't do it, raise your hand as well, so we're not waiting for you. What we're trying to do is wait. I'm trying to give everybody who's got an opportunity to do this a chance to get the software up so they can do it together with us. All right, we've got 80%. We're going to go for it. Now, here's what I want you to do. Look at my screen up here in the top. Hopefully everybody can see it. You're going to hit open, and it says this, the directions how to do this. Open aircraft. I want you to go to general aviation, van RVs, and then RV. I have a lot of extras, and you're going to see why in a minute. I'm going to go to rv10.acf. All right. I put some color on mine. Yours is not going to have the color. Don't worry about it. Okay? It's going to be gray. I've experimented on how we could paint colors on the airplane so people could do their school colors on their airplanes. All right. This plane is our basic model we use over and over again. And why we're going to use this, and then you're going to change it. So this is kind of your test mule, and you don't want to have the kids mess up the RV10, right? So what you're going to do is you're going to save it. You're going to go up and do File, Save As, and then as, say, since we're doing aspect ratios, I would suggest aspect ratio 50, 40, 30, 20, 10. Save it 5 times. First time, save it as aspect ratio 50. Save it next time as aspect ratio 40. So you're going to make 5 duplicate copies of said airplane. Raise your hand again once you've done that, or raise your hand if you're not going to be able to do it because you don't have access to the software. All right? And let me go. I'm going to bring out the right airplane, because this one's colored and we're not going to use. Let me see if I have one right here. Yeah, that's a 50 limit. All right, so here's your RV10. It looks just like this. What you're going to do is you're going to hit File, Save As, and I would save it as aspect ratio. And if you've got students, there's multiple people doing this, you might have them put their name in there. But I would do AR for aspect ratio 50, and then if it's different students, one of the kids' first names or whatever. All right, and then hit Save. And it'll show up, General Aviation, Vans, RVs, at the bottom, AR50. And do that again. Do Save As. AR40. And repeat it so you do every one of them. Raise your hand once you've saved all 5 of them. All right, hopefully everybody's getting into this so they can go ahead and try it. All right, John Williams, John Mycroft, guys, are we saving those? Tom, everybody, good. Excellent. All right. Now, a few more people are saving them, and then I'll show you on your Lesson 7 PDF. You're going to see a table after you've done your aspect ratio calculations and gotten rid of a couple sizes of the airplane that won't work. Then, and this is page 45 on this, then you're going to use this table and you're going to design planes with different aspect ratios. All right, and you're going to go in data collection. So first it's going to tell you open plane maker. Where do you find plane maker? You find it right near X-plane, okay? And then save it. In this case, I have your first name 50, but I'm using AR50 now, AR40, so I know what it is. And what we're going to do here, let me show you, is we're going to go into plane maker under wings. Let me pull this up. And we're going to start changing the different parts of this wing to make the airplane much bigger. So we're going to go into wing 1 and change some things, and then the wing 2. Wing 2 are the wing tips in this particular model. Wing 1 is the main wing, all right? So let me go here. Let me bring it up so we can build this. So everybody watch. Now watch this. I'm going to go into standard. I'm going to go into wings. There's wing 1. Notice the semi-length is 14,136. Now, I want to make sure I have the right airplane here because I'm saving some of me. So this is the Van R5040. I'm going to open the very first one. I'm going to open, actually, don't save. I'm going to open up my AR50 airplane. Open. There it is. Then I'm going to do File. So I've got the AR50. I'm going to go Standard, excuse me. I'm going to go to Wings. You're going to see 14.36 as the semi-length on the first wing, and then we're going to change the second wing. But first thing, what are we changing on that first wing? Well, on the first wing, we're going to set that semi-length to 25. So I'm going to go right here, and I just go up with the little upper pointers. There it is. See how it stretches out beyond the wingtips? See how that changed? If I make that back down to 15, you'll see the wingtip go back out. So we're going to make that 25. Oh, shoot. All right, and we came up with 25 because we said basically the wingspan is 50. We're ignoring it. All right. Then we're going to go to wing 2. And if you look on your table, we said wing 1 semi-length of 25, wing 2 lateral arm of 24.95, vertical arm of 0.25. Let me show you what we're talking about in this. So if I go to wing 2, now I'm no longer in wing 1, I go to wing 2, I've got to move those wing tips out on this. You can see that the wing tips are right here, but this is now the end of the wing. So let's go here, 24. And did I just move the wrong thing on this? I certainly did. Let's go right here. Lateral arm, not longitudinal arm. All right, 24. I think I said 95. And then make the vertical arm. Just go up until you hit 25. All right. All right. Now I've got my wingtip right here. If I hit the space bar, you can see there's my wingtip. And it's probably easier to see with the space bar instead of wire. And that wingtip is in black. If I go to wing 1, see the main wing is in black. There's the wingtip. All right. If I do that, and then I save that airplane, and then I'll go ahead and I will do 40. And I'll use the table, I'll change the wing to 40. And I'll keep repeating this over 30, 20, and 10. And then the exciting part is I can go right into X-plane and fly said airplane. So let me go in here, file, open, let me go to aircraft. I can open the aircraft that way. I can even do it under settings, quick flight setup. Go to quick flight setup, go to open the aircraft. Click on the user interface isn't always the easiest on this. General aviation. All right. And then I'm going to select vans. And I'm going to select, let's see here, we got AR-50. Let me go ahead and do Tom 50. I don't believe I saved that one yet. So there we go. Well, that wasn't it. Let's try again. Try this one. Here it is, Mr. D 50. Whoops. I just, of course, bounced it right out of there by accident. So there's the plane. If I hit it here and I look outside, there's my plane with a 50-foot wingspan. And now I can take off. I can measure my takeoff distance. and I can see how aspect ratio impacts takeoff distance. If you can, go ahead, use the 50-footer and take off. Then make the aspect ratio with the airplane with a 10-foot wingspan and take off. Tom may have a question here. Let me ask you. Tom, you got a question?
I do. I wrote it down, but if you want to put a winglet on this thing, how would you modify wing 2?
What's that? You want to modify wing 2? Wingtip 2?
Oh, I want to modify wing 2 to make a winglet.
All right. Let me go back and take a look at it. I've not done winglets yet, but that doesn't. There's a way to do it. I may not be the right guy to ask, so I'll look it up for you. Wing 2. Oh boy. Well, I think you can start to change a lot of the geometry of that wing 2 tip here if you wanted to. So if that will help you, I will find out if you can go ahead and add a third wing onto the airplane and put your wingtip in that way. So there's a couple ways I might do that. Let me write that down on a winglet. All right, we've got some more questions here. All right. I also think, Tom, without copying out an answer, you might even get a faster answer if you search plane maker adding winglets. Somebody I'm confident has done that. You can just about do anything in there with this. I've not done winglets. And my guess, it might be easier just to add another wing. I have to find that bad boy out. Yeah, right stab, vertical stab, snap to. You would also could do an import wing, but that's a little beyond the range of this class. It doesn't preclude you from doing it. I'm just... All right. Okay, folks. Any questions about how you would do this now, as far as plane maker changing the wing length, and so therefore changing aspect ratio of the airplane? Okay. Let's go ahead. Go to the next lesson on this, so I can start to show you in the 15 minutes we have what more you can do with this. So what you're also going to see in the lesson 7s in these is the trade-offs we all have to make. That's really top designers, top engineers just are best at making these trade-offs. And because what you do is you're going to find out as you increase that aspect ratio, real long wing, long narrow wings, high aspect ratio, you're going to see the takeoff distance decreases. You know? And the more you have takeoff, more aspect ratio, again, you have less takeoff distance, which is great to fly. But what happens is, advantages, you find out there's disadvantages. First of all, you can usually carry smaller loads, and your handling isn't as quite as maybe as precise, and you've got a slower cruise speed. And if you're wondering about carrying smaller loads, just think of your arms. If you hold weights close to your body and then you move your arms out and you hold weights farther away, it just becomes harder to do. It's doable, but that's going to drive up the cost of the airplane, possibly the weight of the airplane, which, oh, by the way, adding weight to the airplane, we just learned, increases takeoff distance, doesn't decrease it. So it's this balance we want the kids to see. All right? Speaking of weight, here's wing loading. You know, and this is a quote kind of us. The Wright brothers were engineers first, pilots second. Still masterful test pilots, but and in here, what we do is we play with the wing surface area versus the weight of the airplane. We look at wing loading, and then we look at wing loading if you keep the constant wing area the same, but you decrease the weight of the airplane. And we go through all those calculations of what the wing load's doing. Then we take an airplane, again we take a van RV10, and we go ahead and start changing this. Now on there, you can change maximum weight on these. Now let me go see if I can get the plane maker here. Let's go back over here to wing. And weight and balance. You can start to change fuel load, maximum weight right there. So you do that go under standard, weight and balance. All right? Any questions on that? All right. Next one we look at is power loading. All right. That's the power to weight ratio on the airplane. And where we can go ahead and we can start changing the horsepower on the airplane. We change the engine. Okay. And we then look at changing horsepower or changing the weight of the airplane. What does that do to performance? Wait, let me do one thing here. It's definitely, yeah, power loading is less than 9. I might have just said 8, and I was like, wait a minute. All right. And let's go in here to do that. Click back out, standard. Let's go ahead into engine specs. And then we can do maximum allowable power. All right, and that has prop engines. Make sure, there's prop engines. There's jet engines on this as well. Let's be careful about that. Okay. In case you're wondering, you can set the burn rate of the fuel, but my guess is they're going to limit that during the competition. Okay. All right. Finally, we put it all together in less than 10. And I'm not sure why I'm just showing a PDF here. All right. We just talked about wing loading and what you change in the wing area. We graph that. We look at the trade-offs on that. Then we get into power loading. We just said, let me explain on the power loading before we get to 10. I kind of jumped a step there. I'm glad I went back through this. A little discussion of horsepower. Brake horsepower is the horsepower you need to overcome drag. But as you can imagine, as in like your car, not all the power you're developing, not all the power you're creating makes it to the tires. Same thing on an airplane. Not all that horsepower immediately is converted to energy that can pull the plane past drag, right? Overcome drag and inertia. Well, that has a lot to do with, for example, propeller efficiency. So what we say is we divide the value we think we need to overcome from drag, and we divide that answer by 0.8, 80% in other words. So if you think of it this way, All right, I'm going to need more than, say I needed 100 horsepower to get flying, but I'm going to lose 20% of it. Well, then I'm really not going to take off, huh? So if I figure out my propeller's 80% efficiency, if I divide that 100 horsepower by 0.8, I realize what I really need is 125 horsepower, because I'm losing some of that horsepower to the propeller, inefficiency of the propeller. Side note, the White Brothers propeller was like 79% efficient. They were amazingly efficient. Then the next issue gets to be, you don't want to run any engine full blast all the time. It's hard on the engine, it's going to hard on fuel consumption, the whole 9 yards. So we talk about cruise horsepower, and that needs to be about 75%, right? 0.75, I should say, thrust horsepower divided by 0.75. So if I have 125 and I say I really only want to run it at 75% of that, I need 125, then I'm going to need to divide it by 75. I end up with about 166 horsepower, even though I only need 100 horsepower to overcome drag. There's inefficiencies in the system. And again, we just want the kids to start thinking about that. All right? So there's thrust horsepower divided by 80. There's by 0.75. We start getting into some questions there. There's maximum allowable horsepower on the prop. You can change that value. Now, we have like 8 minutes here, so I'm going to just go through what we reviewed the engineering method, and we talk about engineering method is that iteration, which I think is getting more and more promoted in school. So most kids and everybody knows about it. It's many small failures to a big success. We try out a new idea, test it, make a change based on the result, improve it, keep doing it over and over again. As opposed to the scientific method where we keep doing the same experiment identical over and over again to make sure that the results we get are accurate. In engineering, we're using an iteration process, which we're trying to improve it, and generally we improve it internally. All right, so in lesson 10, I'll go right to the design here. We're going to start looking at an airplane, 4-passenger. Every passenger carries 20 pounds of luggage. It's got 150 knot cruise speed, 800 nautical mile range, which might be a little bit much. Let me go back up. Let me go get my teachers. Bear with me 1 second. It's a 550 nautical mile range. I knew 800 seemed, I was like, what? All right. So the highlighted information is what the kids are going to have to do, start calculating. So you're given the average passenger's weight's 170 pounds. They need to read up here and go, oh, they're allowed to carry 20 pounds of luggage. So they write in 20 pounds there. Average weight per passenger plus luggage is 190, 170 plus 20. You're going to be carrying 4 of those with the pilot. That works out to be a total of 760 pounds. We use a lot of rule of thumb, and based on some other work by a gentleman, by an instructor out of Penn State, that, okay, hang on. By Skips, and I think it was Penn, not Penn State necessarily. Yeah, Penn State, I was right. Skip Smith from Penn State. This is based on the work he did. The Illustrated Guide to Aerodynamics was one of his books. We're using this as rules of thumbs. So you got the gross airplane weight divided by 30%. There you go. It gives you 2533. And then they calculate the gross. They just calculated the gross airplane weight, and then they figure out the standard wing loading. They think about high wing loading versus low wing loading. It doesn't matter which one they pick. I would, you as a teacher, though, get them to talk to you about why they decided to go high wing loading or low wing loading. They then, again with that previous gross airplane weight and the wing loading, they come out with how much wing area they need. We suggest to them aspect ratio between 6 or 8. So in this case, I made the aspect ratio 7. you'd have to make an assumption there. Then you can calculate, you've gotten the wing area, so if you know the aspect ratio is 7, and your wing area is 149, you can calculate the wingspan being the wing area, the square root of the wing area times aspect ratio, and ends up at 32 feet, and there's your chord of 4.6 feet. You calculate how much horsepower. We said 150 horsepower in this case. We go through and calculate that. The fuel burn is basically fuel consumption is half a pound per horsepower, and that's per hour. And then you have range is total fuel available times cruise speed over specific fuel consumption times thrust horsepower. And that's a lot there, but it's written right down. And then they sit there and fill out this table with their values right here. They got their specs, there's their values. Then they go into plane makers, standard measures, and fill it all out. And then go ahead and fly it. Any questions on that now? Again, the webinars we have on our site, you can show your students going a little bit slower speed. But if your kids are quick, I'm going to post these webinars. They can watch it right here. If you're teaching this and they don't understand where to go or something, have them show you on the lesson where they don't understand in the lesson. Generally, folks don't want to read, and then they ask you to read for them, basically. You answer the question. Encourage them to read this. All right. Any other questions, folks? This is all I have for tonight.